Hi class, I'm not sure if the substitute will show you this video or the solutions, but I'm going to create both and pretend this is the first video you're viewing. This is day 2 of your trig identities. I've got some harder examples for you, but the approach is still going to be the same. You are allowed to simplify left side and right side simultaneously in hopes that you will bring the two closer and closer towards each other. You are, or you should, try to write or simplify all things in terms of sine and cosine instead of tangent, because there are more trig identities that open up for sine and cosine than we do have for tan. Also, you should try to approach all questions with the side that is more complicated looking, because the more complicated or the more messy it is, there's probably more stuff to work with. Okay, so in this case, it looks like it's like a mirror image, and I feel like since cotangent and tangent are reciprocals of each other in terms of sine and cos, I feel like that's the reason why this one has a cos on top and this one has a sine on top. Okay, so I'm gonna try both sides. Left side, we've got sine squared, and this is going to be cos x over sine x plus 1 all squared. And since the right side there's a cos on top, here's a cos, and that's going to be squared, I feel like I'm going to have to open this up, expand it a little bit, or do some kind of shenanigans turning this into a single fraction or whatnot, and see what I get with that. Okay, so we have sine squared, and this is going to be cos over sine plus sine over sine, so that the denominators are the same. So cos over sine plus sine over sine, I'm going to turn it into a single fraction. There it is. And so, oh, okay. If I were to apply the square to this, I'm going to do it in pieces using my exponent laws. I know that if I have an exponent on the entire fraction, it applies the exponent to the top and the bottom. Since these two can be simplified, my left side is effectively going to be cos x plus sine x squared. Now I could multiply this out. This would turn into cos plus sine times cos plus sine. So cos times cos, cos times sine, sine times cos. So 2 of these, and then sine times sine. And guess what? Oops. Cos squared plus sine squared is equal to a 1. So it's going to be 2 sine x cos x. That's about it. Am I going to make an effort to turn it into this? I think it's actually easier if I start my right side. And I'm going to go through the same process, turning tangent into sine x over cos x plus a 1, all squared. This is going to be written as a single fraction. That will be sine x plus cos x all over cos x squared. And if I apply the square to both sides, to the top numerator and the denominator using exponent laws, the cos squared on the top and the cos squared on the bottom are going to cancel out, leaving me with sine x plus cos x squared, which is the same as the left side. So I proved it. Okay, simple enough. But again, it all comes from not being scared, but okay, turning all the ratios in terms of sine and cosine. Let's move on. Some of you might be copying. Remember, this is a video, so you can always come back or just take a picture or do whatever. Question 2. this looks a little bit more creative. I've got sine 4x. We never learned any identities with 4x. There must be some kind of trick. I also see 4 cosine. We've never learned anything like that. But I do remember 2 cosine, right? That is the same as sine 2x. This looks sort of familiar. Anyone? Okay. Oh, wait for it right there. Let's try it. I am going to first take this because there's a lot to expand here. Sine equals 4x is actually 2x plus 2x. That's how I'm going to approach it. Because another reason why I'm approaching it this way is because all the angles that I see on the right side are just single x's. What is the only way I know how to take a multiple angle formula, multiple angle, and turn it into smaller? And that would be the double angle formulas. And so this would be, let's see, sine 2x cos 2x plus cos 2x sine 2x. Now, sine 2x, that can be written as 2 sine x cos x times cos 2x plus cos 2x times 2 sine x cos x. I will factor this out. This becomes 2 sine x cos x, leaving me with 2 cos 2x. Right? Cos x, it's cos 2x plus cos 2x. 2, no additions, just a multiplication of 4. Maybe I can factor out that 2, giving me exactly what we want on the outside. Cos 2x, what identity do I know that changes a cos double angle into a single angle? Well, if you look at your formula sheet, you might notice this is literally that. So we have right side, right? Because, I mean, for sine x cos x, and using my double angle formula, this becomes 1 minus 2 sine squared x. Once again, looks complicated, and yes, there were some manipulation and some factoring that I did that you may not see right away, but I guess that's where experience comes in. Let's move on. This one. Okay, so I think I've seen a question like this before. Yes, I have. So there's a couple of ways you can do it. Just because we did the double angle formulas here, right? You took the sine 4x and equals 2x and 2x. Your brain might be registered to try to expand that. It's like, oh, this is another double angle. This is going to be left side equals cos plus sine all multiplied by cos y, right? I'm going to do that way, and then I'm going to show you another way if you keep your eyes open. Okay, so here left side would equal, open a bracket, cos x cos y plus sine x sine y, close bracket, cos y, that's up to here, minus, open a bracket, sine x minus y is sine x cos y minus cos x sine y sine y. I forgot to mention the reason why I started with the left side is clearly there is much more stuff to work with. It's a lot messier than just cos x. Like if I want to turn this into something that's sine, I have to start adding things I don't know exist. I don't want to do that. Here, at this point in time, your eyes might start looking to see, are there any similarities? Take a look. Cos y multiplying or distributing into this bracket gives you, and I'm sorry for the shorthand, cos x, cos y, so cos squared y, plus this is going to be sine x, sine y, cos y, minus, again, I'm going to multiply sine y, sine x, sine y, cos y, and then multiply sine y in there. A negative is in front, that's a plus, cos x, sine y, so sine squared. They're exactly the same, but opposite inside. Sine, you are left with cos x, cos squared y, plus cos x, sine squared y. You factor out the cos x, leaving you with a Pythagorean identity. That equals a 1. All you're left with is cos x equals a 1. Amazing. If you did it this way, this is what I would call just powering through. Good job. But there's another way. Again, if you weren't tunnel vision, you might have noticed x minus y and x minus y are the same. Y and y are also the same. The left side is actually a form of cos A cos B minus sine A sine B. Where have you seen that formula before? This is the expanded form of the compound angle formula cos A plus B. So what's A? X minus y. What's B? Y. Left side is actually equal to cos of x minus y plus y. And what do you get? Minus y plus y is nothing. You just get cos x. You proved it. How nice it is to not panic and not tunnel vision and have the luxury of stepping back and thinking about it calmly. I hope this will be a lesson for you. And even if you did it this way, just pat yourself on the back for it. It's okay. You're not any dumber for it. You're just, a little bit more stressed maybe. But either way, when you approach identities, it really is in your best benefit to calm down. Number 4. Number 4, I see I could look at this as a double angle formula or a compound angle formula. I could also consider this to be some form of correlated ratios. Because tangent, you know that on the right side is tangent is the same as sine x over cos x. I already have my cos x in the denominator. So is there a way to prove that this is equal to sine x? Well, let's think about it. Left side is equal to cos x minus 90 degrees, huh? Over cos x. X minus 90 degrees. I wonder, it would be much nicer if you remember our formulas. It's actually nicer to have the 90 degree first in this way. I'm actually going to do it like this. I'm actually going to factor out a negative, leaving me with positive pi over 2 minus an x. So I don't know what this angle is, but it's a negative of it now. But I'm also going to use the identity that because the cosine function is even, that means if I have a negative inside the function, it is the same as the positive version. So this is actually the same as that. And using my correlated ratios, that is the same as sine of the x, which is equal to tangent. I probably lost some of you, but consider this one more time. I factored out a -1, which you should be able to follow. And since that's a -1 multiplying with some ratio or some angle here, that's like cosine of negative some angle, a negative inside the function is equal to the same positive value inside the function, because cosine function is even. And we talked about this on day 1. And so there we have it. And this is essentially an angle here. If this is x, sorry, if I have some kind of theta here, this x, 90 degrees minus x gives me that angle. And so the angle that it makes with the y-axis is the x. And there you have it. If you haven't seen the solutions to your assignment, please do so. I have full solutions to all of this up online already. I hope it is of use to you. We'll see you on Monday. If there are any questions that you have for the assignment or even the test, email me. I'll do my best to get to it probably Sunday latest. Okay? All right, work hard, and we'll see you when we get back.